This lesson is about arithmetic sequences. That's how you pronounce it, arithmetic. And these four are all examples of arithmetic sequences. So I hope that you notice that in this sequence, it's to find the next number, they just added 4. The next sequence, we're subtracting half. The next sequence, we're adding 3. And the next sequence, they're subtracting 3. So, an arithmetic sequence means that each new term is found by adding a number to the previous term. So that's the first blank of your definition box. Here's a few more examples. Adding 7, subtracting 3. We say adding because we could say we're adding a negative 3. Arithmetic sequences are very much like linear functions, which is why we're connecting it to what we're doing now. We're going to connect it to linear functions because they're very similar. In the next box, you have a table that you can fill out with these terms. So our first term is 3, our second term is 10, third term 17, fourth term 24, fifth term 31. So we always refer to each number in the sequence as a term, and we can label it based on its position, first, second, third. At the end where it has this nth term, it refers to any term. So if I'm looking for the 100th term or the 9,000th term, the nth term is kind of like the x, like it's a term that we don't know the value of yet. The difference between each term is called the common difference. So if you could go ahead and add that to your notes. So in this case, the common difference is positive 7. So you can just label it just like this and write common difference. You don't need to write the definition. I think you pretty much understand. In the previous slide, our table was written horizontally, but you might see it vertically. This is probably a little bit more how you would see it. But we can still assign these terms to these vocabulary words to our arithmetic sequence. So the independent, the input, refers to the term number. This is like your x. And then the dependent and output would still refer to your term value. This is like the y. So the tables are set up very similarly. X on the left, y on the right. And we already discussed that these are linear functions. You can find equations for functions just the same way you find equations from any table. Finding the difference. Obviously our term numbers are increasing by 1 and our term value is increasing by 7. So this graph went ahead and graphed those points, and if we wrote the equation of the line, it would be y equals 7x minus 4, and that's this graph. This is the function notation or the sequence notation. If I'm looking for the term value, that's the nth term, I need to take 7 times the term number minus 4, or y equals 7x minus 4. So I hope you notice the similarities between the arithmetic sequence and the linear function, kind of following all the same steps to find our equations, to graph it. They're just very similar. So if we want to find the next term, this is in the third box. It says recursion formula. A recursion formula will find the next term. And in this example, the Tn would mean the term that I'm looking for. Tn minus 1, this is like a whole variable all together. And this just means the previous term plus 3. So for example, if I wanted to find the 1, 2, 3, 4, 5, the 6th term, if I want to find the 6th term, I have to take the 6th minus 1, which would be the 5th term. So I take 24 and I add 3 to it. So 24 plus 3 would be 27, and that would be the 6th term. So you don't really need this formula to find the next term, because if you're just adding 3 as you go along, you obviously just add 3 to find the next term. But you need to understand what this means, that this is the term I'm looking for. This Tn minus 1 means the previous term, the one before the one I'm looking for, plus 3. And there's going to be some more examples. So here's your actual formula that you can write down on that long line at the top of that box. So in the recursion formula box, the long line, you can write down this formula. And again, this just means the n is the number that I'm looking for. So if I was looking for T6, I would take T, the one I'm looking for is 6, so 6 minus 1 is 5. So I would take the 5th term plus the difference. If I was looking for the 100th term, I would take the 99th term plus the difference, so on and so forth. So here's an example. To get each new term, I'm adding -5. Adding -5. Adding -5. So my recursion formula, when I'm writing the whole formula, this stays the same, and I'm adding a -5. So the next 3 terms of the sequence, if I take what I had previously, 25, and I add -5, I'd be at 20, and then 15, and then 10. So that's how you find the next terms. You just keep following the pattern. But maybe I do want to find the 100th term or the 1000th term or the 43rd term. So to find any term in the sequence, I have to use the function formula. And here's your function formula. So this means I'm looking for some kind of term. So I take T1, that's the first term. I take the first term and I add the difference times the term I'm looking for minus 1. So you can go ahead and write down this formula on the long line in the function formula box, and we're finding any term. And then when you're ready, we'll go to an example. So here's my 2 formulas. You should already have them written down. Just so that you know, this set of parentheses and this set of parentheses might be switched. So I believe on the last slide the D was first and then the n-1. It doesn't matter because when you're multiplying, you can multiply in any order. So sometimes your formula might look like this and sometimes it might have the D first. Just keep that in mind. So here, I'm starting with 40 and I change by adding -5. This is my same pattern on the last one. So the function formula for this sequence, if I want to find a term, I have to take the first term, which is 40, plus n-1 times -5. So what is the 32nd term? So 32nd term goes in for my n and goes in for my n. So if I want to find term 32, I take the first term, which is 40, plus 32 minus 1 times -5. So order of operations would mean I would do 32 minus 1 first, so 31 times -5 and add 40, and the 32nd term is -115. So let's do a whole example with both parts. First you find the difference. It's always a good place to start. And I'm going to add a -3. My recursion formula, if I want to find the next term, I take the previous term and I add a -3. So my next three terms, if I want to find the fifth term, I take the fourth term, which is 10, plus -3, plus -3, plus -3. My function formula, to find a term, I take the first term, and we can actually plug in that first term. So let me do that instead. The first term, which is 19, plus n minus 1 times the difference, which is -3. So I want to find the 25th term. So I'm going to write my whole formula. So I want to find term 25. And to do that, I need to do 19 plus 25 minus 1 times -3. So 25 minus 1 is 24 times -3, and adding 19, and your 25th term is -53. And that is where we're going to stop today. Tomorrow we'll do a foldable into our journal. We'll add our notes, we'll do a foldable, kind of go over arithmetic sequences just a bit before I let you practice on some things. But go ahead and go fill out your feedback form, and I'll see you in class.